offensive network security through an intensive, hands-on approach, which will teach you the practical skills in the field of penetration testing. The course is accompanied by our online VPN labs, where you are able to attack, explore, and experiment with various machines in order to complete your course exercises. In addition, we host student forums and an active IRC channel where you can find additional resources to accompany the course materials. Penetration testing with Kali Linux is unlike many other security courses and will require a great deal of independent research and study in order to complete the course exercises and compromise the lab targets. To ensure the best learning experience, we recommend that you approach this course by first viewing the course videos for a particular module and then reading the accompanying module in the course lab guide before completing the exercises. You may be frustrated at times, but provided you're willing to try harder, you will find yourself breaking through barriers and learning more than you expected. The whole team here at Offensive Security wishes you good luck on this journey and hope to see you online in our IRC channel. Kali Linux contains over 300 forensics and penetration testing tools. Finding your way around them can be a daunting task at times. In the next module, we'll be showing you some tips and tricks to finding your way around Kali so that you can get up and running quickly. As Abraham Lincoln once said, "If I had 6 hours to chop down a tree, I'd spend the first 3 sharpening my axe." The Kali Linux menu acts primarily as an advertising board for the large number of tools which are present in the distribution. This allows users who might not be familiar with a specific tool to understand the context of that tool and what it may be useful for. Ensure you take the time to navigate the Kali Linux menus to help familiarize yourself with the available tools and their categories. There are a number of Linux utilities that can be used to locate files in the Linux installation, with the 3 of the most common being find, locate, and which. All 3 of these utilities have similar functionality, but work and return data differently from one another. Let's start with the locate tool. I'll quickly open a shell and we'll take a look at the man page entry for the locate command. So from the tool's man page, we can see that the locate command reads a list of files from a database and prints out any existing files found which match a user's query. The database of file names is updated by using the updatedb command. So let's say I'm looking for the Windows version of the SBD tool called sbd.exe, but I am unsure where it might be located in Kali Linux. I would first use the updatedb command to make sure that the locate file list database is completely updated, and then I'd give the command locate sbd.exe. The output of this command indicates that the file was found and is located in the /user/share/windows-binaries/backdoors directory. So that was fairly easy. Let's move on to the which command. According to its man page, the which command returns the path names of the files or links which would be executed in the current environment had its arguments been given as a command in the shell. It does this by searching the path variable values for executable files which match the names of the arguments given to it. For example, if I wanted to check if the Linux SBD executable program is present in Kali Linux and available through the path, I would simply type which SBD. The output of this command indicates that the SBD program can be found under the /user/bin directory. So I should be able to simply type the command SBD from any location, and as this tool is located in my path, it should run. Excellent. Let's move on to the find command. The find command is a more aggressive search tool, able to recursively search any given path for various files. For example, if I wanted to look for all the files in the Kali file system, starting with a lowercase string SBD, the syntax for that would be find /name SBD star. Several files matching this pattern are found on the Kali Linux file system and are displayed to us. The find command can search for other file properties as well, such as file size, date, user ownership, etc. The find command can also take an additional parameter which allows for specific commands to be executed on each found file. I'll quickly show an example of that. Let's say I wanted to find all the files that started with the lowercase SBD letters, and for each file found, I would like to identify its file format using the file command. I know that's a mouthful, but let's give that a shot. The syntax for that would be find /name SBD star, and here I'd be adding the extra execution parameter -exec, and for each file found, I would like to execute the file command on that file name. So let's see what output we get from that. So for each one of these files, which starts with the lowercase SBD letters, the file command was executed, and now we can see the file types for the various files found. Now that we have some basic tools to easily locate various files on Kali Linux, let's move on to inspecting how Kali services work and what's needed to manage them successfully. Kali Linux is a specialized Linux distribution aimed at security professionals. As such, it contains several non-standard features which are important to introduce. One of these features relates to how services are managed by Kali. The standard Kali installation ships with several services pre-installed, such as SSH, HTTP, MySQL, etc. If left untouched, these services would load at boot time, which in turn would result in Kali Linux exposing several open ports by default, something we wanted to avoid for security reasons. Kali deals with this issue by disallowing network services to start at boot time by default, together with a mechanism to both whitelist and blacklist various services. The following module will discuss some of these services, as well as how to operate and manage them. If you installed Kali from an image file, the installation process prompted you for a root password. However, if you're using the Kali Linux VMware image for this course, as recommended, the default root password set in the image is Tor. That's T-O-O-R. So before we fire up any services, we should make sure to change any default or weak passwords to be long, complex, and secure. Let's make sure that we change the root password by giving the command passwd and then entering our new password twice. Now that we have a secure password set, we can start up our SSH server. The Secure Shell, or SSH service, is most commonly used to remotely access a computer using a secure encrypted protocol. As we will see later on in this course, the SSH protocol has additional surprising and useful features beyond simply providing terminal access. The SSH service is TCP-based and listens by default on port 22. To start the SSH service in Kali Linux, we can type service SSH start. We can verify the service is running and listening on TCP port 22 by using the netstat command and then piping the output of this command to search for the string SSHD. So from this output we can see that TCP port 22 is in the listening state, being used by the SSH daemon. To stop the SSH service, I'll type service SSH stop. And we can check once again with the netstat command to see if the SSH service has indeed stopped. And we see that it has. Let's move on to the HTTP service. The HTTP server can come in handy during a penetration test, either for hosting a site or providing a platform for downloading files to a victim machine. The HTTP service is TCP-based and listens by default on port 80. To start the HTTP service in Kali, I'll type service Apache 2 start. To check if the Apache service is up, I can simply browse to my own web server. I'll open up Iceweasel and browse to http 127.0.0.1, and we can see that our Apache server is up and running. The document root of our Apache server is located in the /var/www directory by default. If I wanted to change the index page served by the web server, I could simply change the index.html file residing in this directory. So in this example, I'll simply type echo Kali Linux rocks, and I'll direct that output into the file located into /var/www index.html. If I browse back and refresh the page, I should be greeted with my newly changed index.html. Excellent. Let's turn off the Apache service, and to do that I'll simply type service Apache 2 stop. The service command we've been using up to now to start and stop services is a wrapper around existing system init scripts located in the /etc/init.d directory. Another commonly used syntax to manage services is directly through their init scripts. So for example, to start and stop the SSH service, I could also issue the following commands: /etc/init.d ssh start, and the same with stop. This is also true for other services such as Apache, where we can also use the init scripts to both start and stop the service, or even restart it. Great. So we'll quickly move on to setting service boot persistence in Kali Linux. In certain situations, we'll actually want certain services to persist over a reboot. A good example would be a remote installation of Kali, to which we would want to access through SSH. So if we'll want to have the SSH service start automatically at boot time, we'll need to enable it using the update-rc.d script as follows. I'll type update-rc.d ssh enable. To have the HTTP service start at boot time, much like with the SSH service, we'll once again need to explicitly enable it. So I'll simply type update rc.d, and this time I'll exchange Apache 2 with the SSH service. And now, both these services should persist on the next reboot. Most services in Kali Linux are operated in much the same way as just demonstrated with the SSH and HTTP daemons. To get more granular control of these services, you can use tools such as rcconf or sysvrcconf, both designed to help us simplify and manage the boot persistence of these services. The GNU Bourne-Again shell, or bash, is a popular Unix shell that provides us with a very powerful working environment. It also provides a scripting engine that we can make use of by writing simple scripts and automating procedures using existing Linux tools and commands. Being able to quickly whip up a bash script to automate a given task is an essential requirement for any security professional. In this module, we will gently introduce you to bash scripting with a couple of theoretical scenarios. For the first scenario, imagine you are tasked with finding all of the cisco.com subdomains listed on their index page, and then find their corresponding IP addresses. Doing this manually would be frustrating and take a long time. However, with some simple bash commands, we can turn this into a simple task. I'll start by downloading the cisco.com index page by using the wget command. So I'll quickly give the command wget cisco.com, which proceeds to download the index file from that website. Looking over this file, it seems like the links that we're looking for are mostly found in HTML list entities. So these are the things we're looking for. We're looking for domains, like products, like www, like newsroom. These are the links we're trying to extract. So let's start by grepping out all the lines that begin with href equals from this file. To do that, I'll type the command cat index.html, and I'll grep for specific instances of the string href equals. Nice. So the output of this grep command is still a bit of a mess. We've identified the links that we want to extract here and here. However, we still have a lot of HTML in the way. We notice that most of the lines have a similar structure to them and can be split conveniently using the / as a delimiter. To specifically extract domain names from the file, we can try using the cut command with our delimiter set at the third field. So in this case, this would be the first field up to the /. The second field would be the space between the two slashes, and then the third field would be the domain name that we're looking for. So let's quickly see how that works out. I'll repeat our previous command. However, this time I will cut the output using a / delimiter, and I'll request to have the third field printed out. So the output that we get is far from optimal, and we've probably missed quite a few links on the way. But let's continue this exercise and see what comes out of it. Our text now includes several domain names, as we can see here and here, yet it also includes some useless entries, as we can see here. Let's see if we can clean up this list to include only domain names. We'll filter out all the lines that do not contain the text cisco.com. So let's see how we do that. I'll reissue the last command, and now I'll simply grep for cisco.com. Excellent. So it seems that this time, every single entry is a domain related to cisco.com. However, we see that some of these entries seem to have a double quote at the end of it. We've seen about 3 instances of that so far. We can once again clean these entries out by using the cut command. However, this time our delimiter will be a double quote. So the syntax for that would be very similar to the last one. I'll simply append a cut minus delimiter, and I will use a single quote to surround my double quote delimiter, and we'll be looking for the first field, so that's minus F1. Let's look at the outputs of that command. Excellent. So now we have a nice clean list, but lots of duplicates. We can clean these duplicates out by piping the output of the previous command to the sort command with the -u or unique option. So that will be sort -u. And now we have a nice short list of cisco.com domains, which were extracted from the index.html file. As with most things in Linux, we could probably tidy up and improve on our previous syntax. By using a touch of regular expressions, together with the grep-o command, I can get pretty much the same effect as the previous, more convoluted command. Take a look at this output. Great. So now that I have a nice neat list of cisco.com domain names, I'll pipe this output into a file, which I'll call cisco.txt for further processing. And I'll just check the contents of this file to see that it's what I expect it to be. The scenario we presented required us not only to extract the Cisco domain names from the index.html page, but to also discover their corresponding IP addresses. We can do this by using a simple bash for loop together with the Linux host command. So let's see what it takes to write a simple bash script that will do this for us. Before I begin writing this script, I'll quickly take a look at the output from the host command and figure out which part interests me. So for example, I'll give the command host together with a domain name, which I know that exists. And from this output, it looks like the most interesting part is this line, which actually provides me with the IP address translation which I'm looking for. In addition, it looks like this line can be identified by the string has address. So if I wanted to extract the IP address from this output, I would give the command host and the domain name, and then I would grep for has address, and then I would cut the output using space as my delimiter, and I would request to see the fourth field. Excellent. So now that we know how to extract our data from the host command, let's open up a text file and write a quick bash script which will read all of the domain names from the cisco.txt file and then run the host command against each one of them, providing a nice clean output to the console. I'll use my favorite text editor to create the file cisco.sh and start with a bash shebang and continue with a for loop which will read each one of the lines in the cisco.txt file and for each one of them run the host command against that specific value. Now we know we can clean up the host command output by grepping for the text has address and then cutting the resultant output with a space delimiter and displaying the fourth field of that output. So let's save and then give this script executable permissions, and then execute it. And